Hey there, guys, and welcome back. So, I did say Saturday night would be the secret project reveal. Problem is that I found out / remembered that I had stuff going on this afternoon, so that kind of put a wrench in it. I just got back, and I still wanted to stream, but obviously I'm not prepped for the other stuff, so I spent, 15-20 minutes kind of brainstorming for something I can do really quick, because my brain just plain was not working. I am like food comaed out right now. But hopefully that doesn't reflect in the stream. And what I came up with, point being, is a paper towel holder, which is simple enough to do on stream really quick. Hopefully should just be the one stream. And heck, I even loaded up, just in case, some 2020 cable keepers if we get to it. I pulled a couple different versions off of Printables and Thingiverse and tried them out, and frankly did not like any of them. So at this point, I'm just going to go ahead and make my own, but again, that's secondary to the paper towel holders. So again, if I start wandering off in the middle of the stream, that is because frankly I'm a bit exhausted, but like I said, I wanted to get another stream in this weekend, and because the past couple of weeks have been a bit light, so I didn't want to just, give up because it's already so late. Anyway, I wonder why my taskbar's up right now. Let's go ahead and close this stuff out. Here's where I make my thumbnails. One of those things, thanks to Fusion having to capture my desktop, you're going to get to see some stuff. Control S, close it. That doesn't make my taskbar go away. Let us see, just a second. I wonder what's keeping my taskbar up right now. There it goes. Okay, there it goes on one screen, but not on the other screen. That's fascinating. What if I click this here? No? Alright, whatever. You're gonna live with seeing my taskbar today. Unfortunately. Anyway, actually, the fact that it's cutting off Fusion suggests that it actually locked itself? That's funny. That is weird. Okay. Anyway, yeah, a little scatterbrained again because I am exhausted, so here we go. Paper towel holder is stupid easy. It's one of those things. We're just going to make some circles on the ends. And then the more interesting part, and the reason I'm doing this instead of taking a design off of Printables or Thingiverse, is that most of them do not come with tear mechanisms. In 14 pages I scrolled through on Thingiverse, I only saw 2 that had a way for you to tear a towel off single-handedly. Otherwise, it just keeps on spinning. So I've got my own take on that. I did, again, spend about, well, at that point, maybe 5 minutes after I was done scrolling through all this stuff, brainstorming how to do it, and I've got a good idea. But let's get the base down of what it's going to look like. Again, the base is stupid simple, which is why I think we might have time to do the cable keepers over here too. So we are going to be looking at the wall, so I'll come from the front here, toss in a couple of these guys. Actually, I'm just going to do one for now. And then I guess we'll use number 10 screws because we're going into the wall. And actually, I think I will just use the whole dialogue. Let's see. Paper towel roll. Oh, I guess I should also preface that part of the impetus for this. Where's my tape measure at? It's a bit bigger than my calipers, so I'm going to use tape measure really quick. Part of the impetus for this is that other project that I keep on teasing. Most of the time, because I print in PETG, I actually don't need paper towels over here with my printer. So I just basically grab a paper towel, and then every once in a while I hit the sheet with some isopropyl alcohol if I'm going to do like PLA. But with PETG, you're actually not supposed to put IPA on the sheet. That actually is bad for it with PETG. So I actually have very little reason to have paper towels around here normally. But with this new project, I've been going through paper towels left and right. So now I want a paper towel holder over here. That is the impetus for this. So it looks like we got about 4 inches on the OD. And I'm thinking I want because I'm going to be pulling down, I'm going to want the paper towel roll to be in line with this. So if I have that in line with that, one of those things, we don't need too much plastic above. So let me double check the number 10 screws really quick. Actually, I forgot I had a kit of wall anchors and stuff over here too. So let's see. What's the smallest ones I got? Because this is not going to have terribly much weight on it. Yeah, maybe we'll go second biggest. Or second smallest, rather. Because the smallest ones I have are actually quite small. I say that, but as it turns out, they hold like way more than enough. So yeah, alright, never mind. We're using the smallest ones, which are, says 4 to 6. I mean, I've only got one type of screw in here, right? This is funny. I wonder why. Anyway, pulling out the screws here. Yeah, they all look like the same length, so I don't know why it says 4 to 6. Anchors and screws. You're only going to have one in there, right? Whichevers. Packaging is silly. So let's see. These are not countersink screws. These are flat button head screws. And I've got 6.4-ish millimeters on the diameter. So let's see. And this again is not actually going to be a hole. I'm going to use the whole thing itself. On the head is what I meant. 6.4. Alright. And yeah, I am zoomed way out here. Let's get you a lot smaller. Drag this over here. Drag this up. Try to drag this up. Alright, just delete it then. If it doesn't want to drag, we'll delete it. Alright. We'll go 4 off of that. Whoops, Control Z. 4 off the head there. Then we can start tangenting some stuff. And let's see. I don't think I'm actually going to, so it's a question of how to orient this on the origin right. I don't think I'm going to actually be doing any mirrors in the Z direction. So I'm not sure whether it necessarily matters. I'm tempted to just actually do this. Take a construction line out directly to from the top hole. Make the top hole centered on origin. Because again, it doesn't necessarily matter. And then for my space here, well, let's get the other one set up first actually. Do this, and then that could be equal to that. And the offset equal to that. Fix this and tangent that. And we are more or less off to the races. It's just a matter of how tall we want it. And which is what I was started out discussing, because again, 4 inches right here is what we're looking at for the paper towel roll. So if I just toss this in here, and actually I meant to click that like that. So if that's 4 inches, there's that. Actually, I gave myself 4 millimeters on the edge here. Probably shouldn't have done that. Probably make this a bit beefier. Let's start out at 2 inches and see where we go from there. So that's about 50 millimeters. And then this is, in theory, the height of the paper towel roll coming off this side. So, question is how far from the bottom we want this. It's a bit arbitrary, frankly. Frankly, a bit arbitrary. So, I'm just going to see where this is at right now and then round it out because, frankly, I don't have a particular opinion. So that's about 4 inches. I'll round it up to 4 inches. And let's see, paper towel roll. Just for the sake of modeling, what the heck did I just do with paper towel roll? Literally here 5 seconds ago. There it is. Alright, so we're looking at about 11 inches across is what I've got for this paper towel roll. So for the sake of modeling, like I said, that would be, well, we're probably going to put the part that holds it along the right hand side here, so probably want to go 4 inches here to here. Or why 4 inches, not 4 inches? 11 inches in half. A little bit silly. Alright, so that's our mounting point. And what feels thick enough? I think 5. 5 frankly feels thick enough. And then, like I said, we will go ahead and use the hole dialog today to put these holes in here. And those will be on sketch points, which I think is this one, yeah. That and that. And I said this was 6 point, or not that one actually. Whoops. Good old hit the escape button. So let's see. I wanted the counter sink, and yeah, that's simple is fine. Flat bottom. Well, I'm gonna be going all the way through, so I guess it doesn't necessarily matter. Anyway, so this is going to be 6.3 right here. 6.3. And this is going to be about 1 inch. And this height right here, got to check still. Have not gotten that height yet. 2.5-ish. 2.55. And the diameter on this boy is 3.4, I'll call it. It's one of those things that doesn't need to be biting into the plastic. Wait, what the? Oh boy, like I said, I am exhausted right now, so I am already forgetting what I said. Alright, 3.5. It was 3.5. For some reason, I thought it was something different. And my direction is backwards, it looks like. Oh, this right here, 1 inch. There we go. And yeah, we should be good with that. Not bad, not bad. Okie dokies. There's that. So this is the base. And then we're going to go ahead and make a bracket and for the towel holder itself. And then I'm going to mirror it over, or I might boundary fill it. Yeah, I'm going to boundary fill it because, again, I have different things I'm going to be doing to each side is my idea. So we'll go ahead and boundary fill it and then just flip it over. And well, I mean, that's the problem, right? The problem is that after I do want it mirrored, but yeah, all right, I guess I'll mirror it first and then do the boundary fill afterwards. That's not something I've done before, but it should work out. So let us first, though, like I was saying, get... shoot me. Yep, forgot to make this a component. So left hand bracket. There we go. Now I'm going to delete this and redo it over here just because did not properly organize myself. Do 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 do. And like I said, this is just going to be a simple bracket right here for now. I might come back and actually, yeah, you know what? Let's not do it this way. Let's not do it this way because I think I do want to make it less simple. So we're going to come from this side actually. And we'll be a little bit more fancy with it. So here's this. Oops. Catch up computer. There we go. There's that. And then let's see. Do I want an arc? Do I want a... Yeah, we'll take a spline. Here we go. And you... Wow. Try not to goof this up. There we go. Drag this down a bit. Make this tangent. And one of these things, it's going to be a little... I think I'm going to leave it like this. Normally I like constraining my sketches, right? But frankly, it's one of those deals where this is not really... I mean, it's just minimally functional. So it doesn't necessarily matter. So we can move on to this stuff. So inside of the paper towel roll, we're gonna need, and let me break the plastic really quick. Plastic ripping ASMR. Looks like 44 is probably safe. One of those things. I don't want to make it too big and then have a problem. It's better for it to be a little bit smaller. So I'm just going to call it a flat 44. And then the plastic on the outside, we'll make it 4 millimeters. I do want it to be a little bit thicker than normal. Is that really 4? Huh. Okay. I guess. Alright, in that case, do I want it thicker than that? Because that does not feel safe to me. So there we go. And then, how do I want this interacting here? So we can either have it, you know, tangent to the top here, or we can have it sticking up a bit. Actually, yeah, that's right. I did model it out on the other sketch as being centered on the hole over here. So I'm going to go ahead, find this hole, project it out, and then we will go ahead and go off of that. We'll just center that on the center of the hole. That was the initial plan. There's that. Make sure this is perpendicular. And then this is one of those things where I now have to make sure that this is the center of the hole. So I need to make sure to leave enough space for the whole entire roll on the away from the wall, rather. There we go. So we said this was 4 inches. 4 inches. And then I'm going to go, actually I'll just come back in here because I'm not actually using this. So I'll come back in here and add another 3 millimeters, let's say. And again, this is going to be a construction line because we're not actually drawing it. And we'll make that tangent to the wall. And yeah, the top part of this is constrained now, so now we get to play with this. Make it look nice. Oh, relatively nice. Alright. I think I'm alright with it right there. And then the question is, do I want to do something fancy up here too? I guess I will. The bottom part is splined, so may as well do a spline up here too. And I hit escape again. I really wish it would just accept. I don't like the check mark. Whoops. Back to sketch. There we go. Don't really like the sketch mark function. And how far up on here do we want to go? Maybe like that, I guess. So let us toss this in here. I know it's supposed to be fancy schmancy, but I like having at least somewhat constrained there. And that looks like that's going to be more like 55 then, if that's what 45 is. And let us bring you out. Oh, your tangent, that's why. That would be why. That would explain that one. There's that. Bring this here a little bit. Do I want to tilt this guy up a little bit? Probably. I think I'm gonna Control Z. Just leave it alone where it's at. Probably alright. And I think that's everything I want to put here for right now. And then, like I said, we will go ahead and mirror and now, actually, the reason I'm stopping myself right here is because I'm trying to think how far back I actually want to take this. It's one of those things where I want to say 6 millimeters. And frankly, if it's 6 millimeters, that just kind of makes the rest of this look like empty, wasted space, right? Is what stopped me. Why I stopped. So I'm wondering whether or not I shouldn't bring this all in right now. Or alternatively... Alternatively, I can beef this up a little bit more. It's one of those things, it's relative. The 6 millimeters is quite thick, you know, in real life. This is just a rather large part. Well, relatively large part, I should say. It's a relatively large part. So it's one of those things where I do feel comfortable with 6mm. At the same time, this 2 inches on the back plate frankly feels fine. So I don't particularly want to shrink the back plate, and I don't want to extrude this out much more than 6mm because it feels just like wasted plastic. That, however, may just be my opinion. Actually, so here's a reason to extrude it out a bit more, is that it helps center the paper towel better. So it's one of those things, you have more support around the paper towel. The alternative to that, the alternative that we could do if I wanted to support the paper towel roll more, is to do this and just grab this ring, join, do something like this, right? We will be going in on the other side, but this helps hold everything centered, you know, takes out some of the play. So this is an option. It's not a very good looking option, and it's not going to print particularly well. Actually, I guess it could print, yeah, it could print laying down on that side. So I guess it could print like this, so it wouldn't actually be a problem. One of those things, these holes over here are just going to be what they're going to be. So it is an option if I feel like we want to stiffen up the paper towel holder a little bit. I'll come back to that. It's one of those things, we can always add that later. Because I'm using the boundary fill and mirror, we will be able to push forward any changes. Any changes will forward propagate. So that's one of the nice things about doing it this way. So let's go ahead and mirror this component right now. Component, across the center line. There we go. And then I can change this to right, and after that I'm going to go ahead and boundary fill this body. That way when I make changes on this left hand side, if I make changes on this left hand side that I don't want on the right hand side, they won't be carried over. So we'll boundary fill. See, we got the new body, and remove tools because we don't need the old body. So there we go. Now on this side, I'm going to go ahead and do this side really quick because this is going to be, actually, all right, ready? Unfortunately, most people in the world are right-handed. So the mechanism that I want to put on this thing actually is better off for the majority of people on the right-hand side. So in that case, we're going to load the paper towel roll off of the left-hand side in that case, because the right-hand side is going to have the operation mechanism that I want to put in here. So we will go ahead and do the simple part, which is the paper loading part, over on this side. Let's see, where do I want to start at? I think I want to start on the inside here is where I want to start at. So let's see, this is outside right wall. And it's one of those things, I've gotten used to naming my planes, and I complain about the fact that I never name my sketches, so I'm going to make an effort to start naming my sketches. Make an effort at any rate. I'm not saying I'm going to be perfect at it at this point, but this was the bracket, and this was the back plate. And inside right wall. Or actually, I say right wall, but this is just bracket, outside bracket, inside bracket. Oh no, actually, that one is correct at right wall because we didn't have the bracket yet. That makes sense. This one, however, bracket. Alright, and this, again, is just a super simple mechanism on this side, as previously stated. I'm just going to put a knob over here. One of those things, it can be however big we really want it to be. So I'm going to say an extra inch. And an extra inch is clearly too big. 0.5. That would be 0.5 millimeter. Units are important. There we go. Alright, so one of these things. Again, super simple mechanism. I'm just going to extrude this out one way with a solid object, and then the other way. Let's see. 2 to 3 inches. What do I feel? I'm gonna go 3 inches just to be safe. Minus new body, or new component rather. New component. And we're gonna hop in here and finish the extrusion in here. And this is the holder knob, I guess is what I'm going to call it. Holder knob, knob. And extrude. There's my circle. Let me turn the body off so that I don't accidentally catch it. And minus. I'm thinking maybe an inch is fine. Okay, maybe not minus then. And we need the inside as well. There we go. And then I'll go ahead and knurl this knob afterwards. Yeah. So let's go ahead and knurl this really quick. So this is back of knob. Project. This is knurl. I think that's how you spell knurl, right? Honestly, I may not even be using the word correctly. I know knurls are the little hashes on the outside of knobs. I don't know if the little grippers that I'm talking about are technically knurls. We're going to call them knurls for the time being, though. Turn off some body so I can see what I'm doing. And that sketch right there. And then, there we go. Yep, there we go. So, get our center line in here. Try to get our center line in here. Did I end up with 2 lines again? No, it doesn't look like it. I was trying to figure out why it wasn't giving me the horizontal vertical line automatically. Bit funny. So, our circles. I've done this before on stream. Actually, this should be... no, that's right. This one is tangent and tangent. And this one is tangent and tangent. And then we just decide what our sizes are, and then the what you call it. So let's go with 4, I think. And these actually should be equal, so I don't have to do extra. 3. Let's see. You know what? Let's just make these 4 too. Yeah, it looks fine. So there is that. And then one of those things, actually, the other way I showed you how to do it in a much earlier stream. I actually can't remember when that was. Instead of doing this right here, we said Control Z. We went like this, so 360 divided by however many knurls we wanted. Or actually, it's 180. 180 divided by knurls. And we'll find out in just a second. I think it might be 180 divided by knurls. So if I say 50. Okay, so it might be 360 then in that case. And... It's funny because this guy, I believe, is stuck. Yeah, so even though Fusion is saying it's not constrained right now, this guy is technically constrained. I'm 99% sure. Just one of those things. So, extrude that out. Bodies. Distance all. Flipperoonie. Okay. And then circle pattern. And I said 50, right? Features. This guy. Oh, actually, it might be 25. Maybe that's where I'm getting myself confused. I know one. I'm pretty sure one of them is half, but let's see what happens. Yeah, okay, so I think this is 25. There we go. Yep, there we go. So it's half on this one. I forgot. And let's see if Optimize actually works today. Does it work? It does work. All right, cool. And there we go. Now it is knurled. Frankly, there's no real need for this to be knurled. On this side, we're not screwing it in or anything. We could if we wanted to. We could put a screw on the inside of this. I don't know it's necessary though. So, especially because, well, I guess if we thread it backwards, if we thread it opposite, let's see. Normally you would thread right hand, right? Normally they have right hand threads on. And if we're pulling down on the paper towel, because beards are better than, what do you call them? Mullets. Beards are better than mullets, so we're pulling down on the front hand side. That is pulling right, so that would be tightening the screw. So we'd actually be safe. If we wanted to thread this in, we actually could do that. Yeah, you know what? Let's go ahead. Let's do that. Just for the funs of it. So, create threads. Where's my threads at? There we go. And actually, let me thread this first. The bracket first. Oh, that's right. Our bracket is so thin. Actually, it doesn't actually make sense. Because all I was going to do, the reason I was going to do this first, is because I was only going to thread the back part of this knob right here. But we've only got 6 millimeters to work with. It's not really worth it. Because at this size, at this dimension, diameter rather is what I should say, you can see the number of threads that fit inside of 6 millimeters is like 1.5. So it's not really worth it. So we will just leave it alone. Anything else we want to add on this side? I don't think so. So we're just going to color it. Plastico. I can't spell, evidently. Plastic. There we go. Orange, purple. And now we can hop over to the right-hand one, which is the much more interesting side. So my idea here that I've been teasing for a bit. Again, I want a way that it holds the paper towel roll so I can tear it one-handed. My first idea was to actually put a third piece in the middle here that would clamp over top of the paper towels. And I did see somebody else on Printables. I think it was Printable. No, actually, maybe it was Thingiverse. When I was doing a quick search to see if there was anything I wanted to use instead of doing this stream. I did see somebody do the same idea where you just put a flat bar over top, well, in parallel to the wall, you know, on the wall, and then feed it through, and that works. The second one, I can't remember what the second one was that I saw, but my idea that I came up with is I'm going to make this spring-loaded on this side. So we're going to knurl this on this side so you can actually grip it right. But it's going to be spring-loaded so it charges backwards, okay? And then it's going to have a little rod that sticks out and clamps onto the paper towel roll. That's my idea. We'll see how well it turns out with it. It's one of those things where I kind of have to start it. The rod, when the paper towel roll is full, is going to have to be like up here, and it's going to have to be off-center, because as the paper towel roll gets skinnier and skinnier, this rod is going to have to, you know, continue to make contact, and therefore it's going to kind of have to, if it was dead center, right, it would just miss at some point. It would just rotate around and miss when there's not enough paper towels, assuming I'm thinking of this correctly. So I got to offset it. I got to offset it up more, I'm thinking. And then as the paper towel roll gets skinnier and skinnier, then it's contacting the paper towel roll lower and lower. And the paper and the knob, obviously, in case it's not, the rod, in case it's not obvious, we'll go ahead and just keep tension on the paper towel roll so that it doesn't want to move. And then one of those things, just grab the paper towel on this right hand side, tear against that rod, and it should keep it from pulling the rest of them. That's the idea. That's we're going to see if it works. So, I'm going to have to, like I said, incorporate a spring in this side. Now, the knob that we're talking about, right, technically speaking, can be fixed. So I can actually, for example, extrude right here. I don't have a sketch to extrude on. Give me half a second. So I can extrude just out right here, and that can just be it. It does not have to be, it doesn't actually have to move or anything like that. It can be fixed to this. That's the first thing to state. The second thing to state, actually, so there's a few things. The first thing is printability. You'll see how on this side, we had a little bit of easier time on certain parts of it because of how this was, this plate, if I extrude this out like this as one piece, then I basically can only print it in this orientation with the print bed being down here. Let's say on the X plane, let's say, okay? And printing straight up, in which case all of this mass right here has to be supported. So that is one limitation we got to keep in mind. So if I do want to make this as two pieces, like we did over here, that would save me a little bit of effort in printing it and some material. So that might be a good idea. The next part is, even though I'm putting this in two pieces, the fact of the matter is maybe in that case, I want to square this circle off, okay? And then that way, the piece that goes through into the towel can be locked into place. That way, because, rather, let me back up. Our mechanism, again, has to be off-center from the center of the towel roll. I'm pretty sure that's required. And therefore, if it has to be off-center from the center of the towel roll, then we kind of need a solid area right here to put it on, which right now we have a hole. And if this is free floating in here, this rod that holds the paper towel, then that's can rotate, then that can rotate, and that brings our rod and spring mechanism with it, right, around the edge, which is not really useful. So that is where we're at, and that is the problem we have to solve right now. I'm going to Control Z really quick just because that was an example, and then I will go ahead and get an actual construction line here. Well, I can use that one, frankly. So let's say outside left wall. And I think I will do this in two pieces again. It's just plain easier to print. So I will start out by turning this circle into a square and extruding out the extras. Equals. And okay, yeah, I just need this point on that and we should be good. Yep, there we go. So let's just extrude this out so that we have let's see. All right, so if I do this, just for the record, by doing this, I am saying that this center rod that we're putting in here to hold the paper towels has to be pressed in from the inside. It can't go from the outside. Just for the record, and I'm okay with that, which is why I'm continuing. But the rod is going to be bigger than this hole right here, which is why. So I'm going to go ahead and put that in now. And again, we can continue to use this right here. And I don't know why I just spun the camera. That was a little silly. Project out. Actually, let me go ahead and grab this guy. Oh, that is why this is not visible. Turn these bodies off really quick so that I can project that circle over here. And then we can turn everything back on and that off. There's that. Actually, no, I still want that line right there. So I'm just going to turn the rest of these onto construction and let's get this extruded out. So this is going to go here. We'll figure out a retaining mechanism in a little bit, not immediately because it's not immediately important. I want to go ahead and get the, not ratcheting, but the locking mechanism in first. Name my sketches, try to be good about that. Whoops. And we selected something we didn't want to select. Turn the body off so that doesn't happen again. And we said 3 inches is what we did on the other side, so we will do the same on this side. And that is joined, so we are fine. And anything else I want to do here? Not yet, no. So back to the biggest problem, which is the ratcheting mechanism. So I think I'm going to put this construction line on the inside here. And why did it look like my origin was upside down? Why is my origin up? Oh, because I mirrored it? Mirroring it shouldn't have flipped the Z-axis, right? I guess maybe it does? Yeah, that's weird. That is very weird that the origin is upside down right now. Okay. Inside a bracket. And let us get this torsion mechanism going. So I'm going to go ahead and project out from the other object. Where is my, let's see. Yeah, it was this one. It was the bracket one. That is my paper towel roll right there. And it has a 3mm offset, but I'm okay with that because if our gripping mechanism here, I keep on changing what I'm calling it, but if this mechanism right here goes an extra 3mm, I'm completely okay with that. You know, it's not hurting anything. So, one of those things, I think I want to start out right here. I think this one, I think dead center, straight up and down is where I want to start the, on a full roll. Because one of those things, when you're pulling on the roll, and there's my 2-line bug that everybody loves. When you're pulling on the roll, you don't really want to have to pull up over the paper towel. At best, you want to pull off the top of the paper towel roll. So that's why I'm starting from the top. And this can be construction lines here. That is here. And now how beefy do we want this to be? It does want to be kind of beefy. So I guess... the other question is, do we even want it to be plastic since it is highly likely to snap? It is the most likely feature on this whole entire project to break. So maybe we want to actually use a bolt or something or a rod. Yeah, you know what? Back to my 8mm / 5/16 rods that I keep on using in projects. I think I will go ahead and use one of those because again, this is the most likely feature to snap. So we will go ahead and go with our 8mm, and that should be fine. That way I don't have to make it extra beefy also. So that's the rod. I'm going to go ahead and draw in the holder for the rod as well. So it will thread through this, and by thread I'm using that term loosely. I do want this to be a bit beefy, so we'll make that 5mm. And then, let's see, may as well, while we're here, put the whole entire arm in. So, let's see, back to, it needs to be, where is my bracket? Let me get the bracket in here for reference. Now, it occurs to me that even though I'm using an 8mm rod here, it might make sense because of this right here. So let me, I'm also going to pull in this, I don't need to pull in this rod actually. I can just toss this in here really quick to check. What offset did we put here? 6mm, okay. So we had 6mm around this rod. So the point being is that as this paper towel roll gets lower and lower, at some point this rod is not going to make it past this lip right here, right? That is the idea. In which case it should probably have a little cap on it that actually makes contact with the plastic, or with the paper towel rather, a plastic cap that makes contact with the paper towel. That way the 8mm rod can reach over top of this lip right here. But the plastic, so if I make this 6, we can do both of those at the same time. The plastic sheath will be on the other side of this bracket. so it can reach down to the paper towel roll. I think that makes sense. And it's one of these situations where at 6 and 6, this may not work perfectly. It may be that I get down to the last 10 sheets or something like that, and it's not hitting. So one of those things, we may have to revisit this and reprint this sheath to be 7 or 8 millimeters. But for the time being, we are going to go ahead and leave it as is. Let's see. Anyway, back on to where exactly this is going, because again, we want this to be offset. So I guess that means it needs to be back here. So let me go ahead and draw a circle in here, and this circle, and I somehow, what did I accidentally coincident that with? So that's fine, but I should be able to, yeah, there we go, that's what I was looking for. That's what we're looking for. So in theory, let's say this is the lowest part of the paper towel roll that I want to connect, which is right in line with the rod that goes through there. So that's how we would constrain that. Now the next question is, can I move this? I actually don't know, because it's saying that I'm not constrained right now. But if I have 2 points, it makes sense to me. So if this is a perfect arc, let's say, and I have both ends of the arc constrained, then oh no, I can go backwards. Okay. Yeah, that just changes the... Okay. So, how do we define this? Because obviously, so if I move this forwards, right, you can see how it actually gets bigger. This is the arc that our rod is traveling right now. So you can see the arc actually gets bigger. So we want this to be such that the arc only ever gets further in. I think that just means that it needs to be, let's see, somewhere in this range. I just don't know how exactly to define it. I'm not sure about the math. So for the time being, I think I'm going to actually just arbitrarily choose this point right here. And actually it says that it cannot resolve that point, which is kind of... Okay, so it actually never coincidence that point, even though it looks like it. So it should be able to do that. Yeah, there you go. So you can see how it's just barely off there. That's the closest it gets. So this should, I believe, work. It's not going to move at the same rate as you can see all the way down. As you can see, it gets it closes the distance a lot quicker right below this line right here. It kind of arcs out a bit here, and then from this point on, this perpendicular point on, it reaches the bottom a bit more quickly, it looks like, even though it's a circle. I don't know, it may just be an optical illusion on my part, but point being is that's our center point right now for where the hinge is going to be, so I'll go ahead and throw that in there. The next interesting question will be how exactly we print this, because I just put this on this line. We've got the other part coming in here, so this is going to be a bit interesting to figure out. It may be that we actually cut out part of that rod and just make this solid. That's definitely an option. The other part is, does this need to be metal as well, because we're putting a spring on it? It shouldn't really, no. It's just going to hold the spring. So I think we should be fine. So this is our hinge that I was talking about. I'm going to go ahead and leave it at 4 millimeters. But the ID is up for debate. Alright, you know what? Just to be consistent and just in case we need to turn this into a metal rod for some reason, I'm going to go ahead and leave it at 8 millimeters as well. And then we can just go ahead and do our tangents here just to make it look pretty. Tangent. All right, there we go. And there's our arm, our clamping arm. And actually, I said, so this is a bit of wasted plastic is what I'm getting at here, what I'm about to get at. So I'm going to go ahead and Let me think. You know what? No. Never mind. I take it back. I said I wanted this to be meaty anyway, so it's going to be meaty. That's just how it's going to be. So that is that. Anything else I want to add at the moment? I don't think so. So we're going to go ahead and extrude this out. And it's going to look a bit funny for right now because, again, it's partially inside that window. We will resolve that in just a minute. So I'm going to extrude just these parts for right now. And let's see. How thick? Honestly, it really doesn't, because the forces are going to be tangential to it. It doesn't need to be that thick. And maybe we make it a little bit thicker. Yeah, well, let's call it 4 millimeters and be done with it. Again, the forces are going to be tangential to it. It's going to be printed in this orientation laying down most likely. So all the forces are going to be directly into the layers, not against the layer lines, which means that it's going to hold up just fine in theory. So probably not something I need to worry about it. So this is the clamping arm. Actually, you know what? I should probably clamp, and then let's move this guy down. Actually, one of those things. Sometimes I think ahead, it's not. Sometimes I don't. Oh, here's another one that I haven't been doing. That comes back to bite me when I print it, but not when I'm streaming. So it's one of those things I only ever regret it afterwards, after the stream. This is clamping arm. Naming my bodies. So this, I look at, on stream we look at this and you can see how all the components, because I basically do one body per component, it's not really that big of a deal on stream. But the second I load this 3MF into Prusa Slicer or whatever, it sits there and it only uses body 1. So I end up with like 10 body 1s in a assembly. So that is one of those things. I really should start naming these two. I'm not going to bother doing it right now. But I actually didn't mean to open that up. I meant to open this up because I noticed we had a missing line in here. But it's something I'm mentioning because, again, I open up any of my models and it's just body 1, body 1, body 1. And then I got to pick through and figure out which one is which. So anyway, this is one of these things where, and I wish so set the orbit, set orbit center, there we go. Oh, that did not work. Okay, Control Z. Okay, Control Y. Never mind. Can I set orbit center here? Okay. One of these things where I'm so far off center because of the size of everything that orbiting is a bit wonky. So set orbit center really did not help me right there. Whichever. I'm going to live with my mistakes. Alright, let's see. I'm going to procrastinate it a little bit here. And we're going to come up here. And just do the clamp really quick. New body, new component. Clamp rod. Extrude. Not that guy, that guy. I hope I have that right. It's one of those things, because it's going to select the profile. Nah, it should only be selecting that profile. We should be fine. Alright. Let's see, I want to go from the backside here. Let me cry some more about the way this is orbiting. So I want to go from the backside. And now I'm lost. There we go. And now we want to go like 6 inches, 7 inches. Let's go minus 7 inches. You know what? Let's go 5. I take it back. Alright. Clamping rod is fine. New body. Anything else I want to fix? I don't think so. Alright. There's that. And then we can do new component. Rod sleeve. And one of those things. this could be organized a little bit differently. I've got all these on the same level. It's not necessarily a problem, but it definitely, it's potentially not completely correct. This should go to object there and then offset. Actually, you know what? Let's not do that because I got to print this. So I probably want it only the minimum that I want it to be, which is, let's say, 4 inch, 3 inches, 3 inches. Since I got to print it, may as well only do what we want, what we are actually going to use, and then do that from here to put a back end on it. -3. Just needs a 3mm wall on the end. No big deal. So there is that. Anything else we need to do here? No, I think we're good to go ahead and put the spring mechanism in now. So, come back here. Actually, you know what? Really quick, let me just color those guys because this all looks ugly. Plastic. You can be pink. You can be blue. I still got to pull those other colors out of the other design. I actually can't remember which design that is. Oh, alright, so I'm not going to model it up right now, but when I actually make this, I'll cut this rod a little bit longer and then use, whoops, and that is the appearance tab, grabbing all those faces. That's what that was just now. I'll cut this a little bit longer, this rod right here a little bit longer, and then use those what do you call them? Collars. Those collars I bought for 8mm rods to hold it in place. And that would end up being one on each side in theory, because it can slide back and forth. If I extended this sleeve all the way out to the end, which I can't actually because of this bracket, because again it's going to interfere with this bracket. But yeah, anyway, I'll figure it out. The fact of the matter is that that does mean if I gotta put a collar in front, that I'm gonna run into a problem with this bracket. So I'm gonna have to sort that out in a minute. It's one of those things. This whole entire mechanism can slide in. There's no reason why I can't slide in or slide out, however you look at it. So that is that. Let's see. So we're going to have to extrude out here. Again, I think I might just make this my life simple here and extrude this in like this, just so that it doesn't look completely awful, and then extrude this out this way. And let's say well, actually, let's do it this way, just in case I drag this out. Whoops. Let me turn that sketch off really quick. Just in case I drag this arm out, so long as I drag this arm out and reposition this arm prior to this extrusion I'm about to do, then this extrusion will automatically update. But I'm going to put an offset in here of 10mm. And that's how much space I will have for my torsion spring. And that should just join the one. Yeah, okay, that is just joining the bracket. Good, good. And now I think all I want to do, let's see. So when I do the spring, chances are I'm going to want to do the spring so that the tail is on the same side on both sides. So the torsion spring will roll upright and it has a tail on both sides. I think I'm going to have those two tails parallel. Put the one tail through a wall on this side and put the other tail through here or onto here, but down here. I'm going to start it out down here, like way past its final point, so all the way down here against this back wall, and then torsion it upwards, and that will pre-charge the tension. That way, at its final resting point, which we decided was right here, it still has tension because it was started its pre-tension down here. The fact of the matter is that it probably should have some extra tension, so I'm kind of tempted let's see, what's the best way to do this? I kind of tempted to actually tension it using a plate on this side. So on this face, if we put a plate on here and then use that knob, I'm calling it a knob now, I just changed terminology, but use a knob on here to add tension to it, that would actually be easier. The only question rather is how exactly we get that knob. Well, A, get that knob on there because it's going to be free spinning, obviously, and B, lock that knob in place so it doesn't move after we're done tensioning. Those are the two questions, the $2 million questions. Let us see. So there are a couple options. One is that I could hex this edge right here and then back to put the tail, attach the tail to both sides, and then like I did for the handlebar input on the arcade stick, just pull the knob off of this hex on this end, pre-tension it, and then put the knob back onto the hex. And again, the torsion spring is going to be pulling that in, so it's not going to accidentally fall off, and the hex is going to hold it in place to keep it from unwinding. That might be how I do it. I think that's a reasonable way to do it. Okay. So this 10 millimeters I decided is how much I'm going to have for my tension spring. That may be more than enough. That may be actually overkill. But I think that's where I'm going to start out with. So I'm going to go ahead and from here, let me just rename this sketch really quick. Clamp assembly, because we're trying to make sure that we keep ourselves organized, trying to slowly build up habits that result in long-term success. This is a back of. What is this? This is torsion rod, I guess. Torsion rod. I guess that's what it is. It is what it is now. So let's go ahead and add the hex onto here, and while we're at it, I guess we may as well also add the actual knob itself. So let's turn some stuff off, and we don't really need to see anything else, so that's fine. We have all the all the projections we need is what I was trying to say. So this would be the hex that we're just going to extrude out, and then this is our knob. So however big I want the knob to be, so let's say, yeah, an inch is fine. There we go. And I actually can go ahead and put the knurls in here as well. Not as well, but right now, instead of doing it as a separate function. Or not a separate function. We will need another function, but instead of a separate sketch is what I meant to say. There's that. There's that. That is equal to that. And then my tangents. That's tangent, that's tangent, tangent, and tangent. And then we just need an angle here, which is the number of knurls, so 360 divided by 25. And then we can set this to be like, you know what, let's do 4 again. I realize I have fewer rather of the knurls this time, but I think the depth on that is probably fine. This is the depth of the nadir here, is how we define this. So I think that's probably reasonable. So let us start out by putting this hex end on the end of this knob rod, tension rod. And I guess we will have a 5 or 6. Well, all right, one of those things, since I like being consistent, I guess this will be a 6 millimeter knob that we're going to make. So there is that. This is tension knob and attachment is what that sketch is. And now we can go ahead and actually create the knob itself. And before I do that, just because I like constrained sketches, we're going to go ahead and define this as, there we go. Obviously this guy is stuck right here, but let me go ahead and drag him again really quick just to see. Yeah, all right. I don't actually think he has any way I think he is actually constrained is what I'm trying to say. It's just a fusion bug. But I'd be really interested to know what Fusion thinks is not constrained about it. Make sure we grab all these guys because we want to cut those guys separately so that we can do the pattern. The circular pattern. And in case we ever change the size here, we can go ahead and make that to object. This is tension knob right here. There's that. And now we can go ahead and do, not that though. These guys, these three. Distance all. Okay. Yeah, okay, it looks like that only did the knob. Good. I didn't accidentally cut something else. And now we go ahead and circular pattern, just like before. That is my one feature, correct. This is my circle, yep. And then this is 25 divided by 2. I don't know if they accept. No, they don't accept. So let's make this 13, and then I will come back in here to this sketch and change this to 26 instead of 25. And now the knurls should, yeah, they're smooth now. Before, I don't know if you caught that, but they had a high spot in here where it was flat, or not necessarily flat, but not properly curved, because the numbers did not line up. You, Gale. What kind of bugs are we referring to? Because when I say that this is a fusion bug, this that is very benign, and therefore I don't ever worry about it. And frankly, it may not be a bug. It may be a technical issue that I just do not appreciate. So it's one of those things. I don't know what we're classifying as bugs, because frankly, bugs are extremely rare in Fusion, like actual program breaking bugs. So I do like to complain a lot, though. I definitely do that. And we'll make you white. Yeah, I mean, I'm calling it a bug. Again, it could be just a feature that I do not understand. There could be a bit of math behind there that says that it is not constrained, and I just completely disagree with it because I don't understand the math, because I am not intelligent, but it is one of those things. Let's see. Actually, what I should have done here, back in this sketch, I also should have put my little hole for my spring. And let's see. Probably going to go with the smaller spring for this guy. It probably doesn't need the bigger spring tension. So 0.559 millimeter. We're still under 1 millimeter, so I'll just call it 1 millimeter, and then I'll have to drill it out anyway because my printer does not print below 1 millimeter, or at or below 1 millimeter consistently. So nominally 1 millimeter here. And let's see. I guess that can be, so in theory, it really depends what my spring back is going to be here when I wrap this spring. I'm not sure what the spring back will be for the ideal placement of this guy. So I'm going to arbitrarily just call this offset by 3 millimeters. Oh, no, 1.5 millimeters. I take it back. I was going to say about where it's at right now is probably fine, is what I was going to say. And because of the size of it, I just did not recognize that that was as close as it was. So let's come back in here and make sure we have that hole. And now I can come back to the clamp, and let's put the hole in the other side as well. Or am I going to do a hole? Because I wasn't actually sold on that. So it doesn't necessarily need to be a hole. It could be a kind of L-shape bracket. Although that would be more difficult based on our orientation here. that would be more difficult to print in L-shaped bracket. No, it wouldn't. I take it back. It would not. It would not be that. No, you know what? No. Let us go ahead and do a hoop. Yeah, I think that's what I'm going to do. I'm going to do a hoop. And the reason is I kind of do want an L-shaped bracket. So let me, hold on. I'm saying all this stuff and it's probably not getting through coherently. So let me come in here and just draw it. What is the best way to draw this? That is actually an excellent question. Let's turn this body off really quick because I don't need it for the moment. I guess I'm going to do a tangent plane on the inside here. And my reference plane, where is origin? There we go. Tangent plane, right about that. So I kind of want it perpendicular to this wall is my biggest. Actually, I should be going straight up and down right now, right? So this should be accurate. No, I'm not going up and down. That's right, I'm not going up and down because we're offset. That is why. So let's see, what's my best way to get an perpendicular wall to these? Oh, there it is. That's what I want. There we go. Plane through two edges. There we go. I can do this. Because this is a circle right here, I'm going to go through the dead center of the circle, and then I will just extrude from a different angle. So even though Fusion is showing that in a really weird place, in theory this plane goes right through the dead center of the hole right here. In theory. Alright. So let's get this in here. Yeah, I just need that front wall, that's fine. And let's turn the rest of this off really quick. So, what I want, or what I was talking about. So when I was talking about an L-shaped bracket, this is what I was talking about. So the arm, the other arm that's not going through this tension ring right now, would come up and sit in here and push against this. This is what it'd be pushing against to move this arm, move this whole entire clamping arm right here, right there. There we go. So to push against it, that's where the spring would be pushing. That's kind of what I want. The problem is that this overhang right here is kind of killer, right? And I need something to retain it against this wall because, again, it's going to be pulling this knob into the rod. So I need something to keep it from just springing back towards the knob and being loose. For that reason, I'm going to go with an arc instead, a hole, a loop, whatever you want to call it. And let me just make sure that this rod is dead center where I think it is. Not that one, this one right here. Yeah, okay, it is dead center of this hole. Just wanted to make sure. A little bit of a sanity check. So, let us go ahead. Toss and center line in here. Actually, Control Z that, just because, again, I'm always paranoid that Fusion is going to grab a face instead of the sketch lines I already have. There we go. And this, again, is just going to be 1 millimeter. And then I'm going to put a 3 millimeter wall around it. This is actually, I won't actually be able to get to this with my drill, now that I'm thinking about it, to clear this 1 millimeter hole out. So I'm actually going to call this 2 millimeters. And the spring will be a little loose in there, but that's alright. That's not that big of a deal. We have on this clamping arm, obviously, enough thickness, so we can just tangent this so that the spring is as close to this wall as is possible. And as for the rest of this, one of those things, I think this one I'm going to go ahead and have perpendicular tangent to the circle. So it's not much. But on the other side, I think I'm going to do a bit, and by a bit, I mean maybe even all the way down here. Nah, that seems like too much. I want more of an angle on this side, just because, again, the spring is going to be pushing this direction. This is where all the force from the spring is going to be going. So, and also the spring is going to be pushing basically into a layer line. so it's going to want to split. So I kind of want to beef this side up. That's the point. I guess I'll just define it this way. It's one of those things, not particularly scientific or anything like that, but functional. Now, the next trick here is, again, we are center to this hole right now. So if I extrude it right now, that's going to be a little bit of a problem. I guess now I go ahead and put my tangent line in. Nah. Okay, this hole is 8mm. There we go. That's how we can do this. So we can extrude this, and then we'll offset by 8mm. Maybe, no, I actually want more than that. So my hole over here, I want 1.5. So we're going to want an offset of 4mm for half the circle, half the 8mm circle, plus 1.5. And we are going in the opposite direction right now. There we go. And now for the thickness of this, I'm kind of feeling comfortable. I know I said that it needs to be a bit thicker, but it's thicker in this direction. This vertical direction doesn't necessarily matter. So I will extrude it only 3mm, and this again needs to be negative. There we go. And this will be a join. Oh, actually, I take that back. We got to hop in here to the clamping arm and then extrude it, because we made our sketch in the wrong object component. Alright, let's try that again. -4 plus 1.5. -3. Join. There we go. And this sketch, get a name on it. Get a name on it, not enter it. It's silly. We will call you clamping arm spring capture, I guess. All right. And that is that. Oh, that is not that. We have to come back in here now because we played with the geometry here a bit. And hit the combine button here. That on that. Cut, keep tools. That way, let me close that so we can see it. Actually close these guys too so we can see it. That guy and that guy. There you go. So you see how it took a bite out of the, right here. It's not the prettiest thing in the world, but, and actually, nah. I was going to say, actually, we may just want to cut the corner off. Just go back and make a straight line back here in the rod square. So, in theory, I could just do something like this, you know, just grab this and then only extrude out this much so that it's always like that. But I think that's a bit unnecessary. The next thing that I want to consider really quick before we call it done is that, actually, you know what? That wouldn't be so bad of an idea, only because what I was about to do was extend this out a bit. So, let's see. I'm just a little concerned about this falling out. Is the only thing I'm concerned about. The rod right here, this guy falling out that side. That may just be me being paranoid, is the only thing. It may not be necessary. So even though I want to extend this out a bit further, the problem with extending it back forward and why I may just want to cut this to be a different shape is because the spring on here. So if I extend this out, that starts interfering with the spring that is right on this rod, which again, the rod is only here because I put it here. In theory, the rod could be a number of other places that would be acceptable, but I don't particularly see a need to change the design at this point. So we may just leave it like that, and one of those things, I'll just point my 0.05 offset around this rod. That way it's snug, and just assume that friction will take care of me. So I think that is actually it. And this did in fact take us an hour and 20-ish minutes. So I don't think we will be going to the cable keepers today. Again, the cable keepers I was tossing on there because it was going to be a really quick and simple design, and I figured maybe if we take 20 minutes, it is what it is. But it's one of those things. Again, I'm a bit exhausted and it is a bit late right now, so I don't think I really want to push it. Is what it all comes down to. Plastic. I can't. That is not where my fingers go. Plastic. Where's red? I want red in here. I want actual matte red though. There we go. There's red, and then let's see. Yellow. Yellow's fine. Yellow's close to orange. Red is close to purple. So that's where we're at. Just looking at it from this, from this far out, I'm kind of curious whether or not this arm needs to get a bit bigger. We might need to get this arm a bit bigger. Otherwise, I guess we'll see what happens with it. One of those things, if it needs an iteration, it needs an iteration. I wasn't really hoping to do a second stream of this, so maybe that just goes into a, into a project update stream instead. But yeah, I think that's everything. So, yep, last minute stream. Thank you guys for hanging out with me. Hope you all are having a wonderful day. I'll say that again in just a second because I'm going to do the rest of my 20-minute outro first. Let's see. So my desk has a bunch of stuff on it right now. Among those, I have the what I have put together of the sanding jig. We may need to make a change to the sanding jig. Basically, the rods is what I have together right now, and they only have the rods. Each end of the rod only has one point of contact. It has the one T-nut. Normally, I have two T-nuts on everything, and that's because specifically that is what you need in order to keep things straight. We didn't do that with this design, so one way to solve that is to connect the upper and bottom rods on each end, and that would keep them straight. Otherwise, right now they want to pivot. I cranked the T-nuts way down, and it's pretty sturdy right now, but that may be something that needs to change. Otherwise, in order to finish the sanding jig, I need to get back to work tomorrow and cut the rest of the extrusion pieces. Otherwise, I have everything printed out for that, so look forward to an update video on that. The special project that obviously is not being revealed at this very moment is very close to done. Again, I would have been able to do it tonight, except for I forgot that I had plans tonight. So that is maybe 45 minutes, an hour away from being completed. And the reason I didn't do that today is because that would put me starting a stream at like 9 o'clock, and I don't start streams after 8 o'clock because, again, I get tired. So that is hopefully going to be tomorrow. Again, we'll see what happens with my day today, tomorrow. I'm not actually sure how that's going to play out. So hopefully tomorrow I'll be able to finally show you guys that. At that point, once I have the special project done, I do have to, that's been consuming most of my time, so I do have to get back to working on the mini CNC project. Back to that needs the LCD. The 2x16 LCD does not have any documentation in the Marlin stuff as far as I could find, or online. So I'd like to try to get the 2x16 display working, even though I don't intend to use it. So that's what I want to work on next. Obviously, that's not something that I'll work on stream. That's going to have to be one of my projects that I work on off stream. Which means that we need to come up with other things to do on stream. The Stream Deck is... I got to take another look at that. Again, that I may just have to do another redesign on that one, because despite opening everything up by so much, it's still having issues with the slide. So I may just have to bite the bullet here and go a different route with it. Unfortunately, it's one of those things that happens from time to time. From time to time, you can't salvage a design. Otherwise, with the arcade stick, I have not had time to do the version 3, which would be the combination of versions 1 and 2 on the sliders. I haven't had time to do that yet, so I still need to do that and print that out. Otherwise, again, once that is back in place, then we will place some more tooth and tail on it. And I did, back to these cable keepers right here, Even though I don't like the cable keepers I did print some out, so it looks like less of an absolute mess with the cables. It is much more organized now, but unfortunately those cable keepers are way too loose. So I do need to go ahead and get these guys built. So maybe this ends up being a stream tomorrow, just a short little stream since I have so much on my plate, just to get a stream in. We'll see about that one. Otherwise, the stream animation program, my perennial ask me about later thing. What I have to say about that is please ask me about it later. Obviously, like I said, I've been busy with all the other stuff so far, so I have not actually done anything with it. Unfortunately, I apologize. And I believe that catches us up. So once we got all that stuff out of the way, then we can move on to the next program next project. And I probably will sprinkle in random stuff like this paper towel holder now and again while I'm working on the more time consuming off-stream projects, just to have something to stream for the time being. Otherwise, yep, again, fun stream. I actually am feeling less exhausted right now than I did when I started the stream, which is really good. So again, thank you guys for hanging out, and as always, I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.